My name is Tapio. It's actually an old Finnish name which is referring to the forests. So I have seen artificial intelligence development for more than 20 years, but I was still astonished to see a 4-year-old kid use AI applications by herself last year. And during the recent weeks, I had a few holidays and I condensed 5 main themes that led to the development of this technology from my point of view. And I named this presentation, Why Are We Living the Age of AI Applications Right Now? So the long innovation path to this bedtime story magic. But let's start with those bedtime stories. So I last year observed a kid that was using AI to develop these. So these are real bedtime stories that the 4-year-old kid was creating. So she did not know how to write and she did not know how to read, but she still had very precise visions on what those bedtime stories should contain. So these are not just some arbitrary pictures and these are not just some arbitrary texts. So they were like 1 or 2 page long, but she had very precise long prompts what those pictures and stories should contain, and typically the AI needed to iterate this many times. And then she was able to listen and view the results, and if there was some mistakes, again, there was more iterations. So seeing this interaction live, it sort of, in a way, blew my mind still. And as of myself, I have been lucky to work with a lot of smart people throughout my professional career. So I started in AI research. There was a lot of smart people working there, for example, Seppo Linnaima. And throughout my career, through healthcare, retail, and tax domain, and now recently in HR, I've seen many SaaS companies grow. And there's already one unicorn in this family, and let's see where the future will take these companies. If you want to see more, you can check my LinkedIn profile. And if you prefer a written version, so I know that some people prefer like listening and seeing pictures, but I also wrote these ideas into a more traditional PDF, and it's available in the Cornell University online archive, and you can see the link here or use the QR code. So what was the research method, sort of what I used? Well, I started from this observation that, well, basically this kid is just speaking to the phone in Finnish, the phone understands, and then images and text come out, and it's also speaking back in Finnish. And then I was asking, like, where did this technology actually came from? And then I started to sort of describe the architecture and technology components that is basically within this piece of technology that is making this happen, and then going through that, also using my experience. And in the end, I condensed those into 5 points. We will go into those, and there's a bit more elaborated versions of those 5 points, or 5 main themes that we will be going through in this presentation. But let's start from AI applications. And I want to emphasize the application here. So I'm using like concrete apps, not only philosophically what AI is. I like this Bill Gates saying that he has seen 2 revolutions. One was the graphical user interface, and now ChatGPT was the other one. So I think Bill here is referring to not AI, but the way that people and computers are interacting. And AI development is not slowing down, so ChatGPT is not the whole story. There has been numerous cases, like from speech to text and image recognition, and different, let's say, narrow AI cases during the last 15 years, where the AI has bypassed the normal average human levels. So there's some sort of AI applications that are narrow, and then there are some more general AI applications that can be used for multiple purposes. And I want to emphasize again the application, not only the philosophical concept. But let's start going through now these 5 points that I, in the end, came up with. So 5 points would be, first of all, there's calculation units. So basically CPUs and GPUs that are necessary for this technology to exist. Then there's enormous data sets. How did that came to be through World Wide Web and open data? Then there's mobile small computers in each and everybody's pocket. So billions of computers these days, and one of them is used by the kid. Then there is the immense background cloud scale, hyperscale infrastructure, which is partially serving the needs of these billions of computers. And in the end, there's scientific breakthroughs that made this whole AI part happen. And to elaborate a bit more, those 5 points, CPUs and GPUs were meant for other purposes originally, not for AI. Data was meant for other purposes, so I would say that it was more the killer application of the internet invented by Tim Berners-Lee. Calculation scale from the mobile technology point of view was meant for other purposes, not the AI. It was more the evolution of the communication technology, and recently through iPhones and the smartphones, which are essentially small computers. And calculation scale, that happened induced by the demand of these billions of computers. So now, recently, hyperscalers are building data center farms that require nuclear power plant scale electricity consumption. And even with these 4 previous points, we still need a lot of scientific breakthroughs from neural networks to backpropagation and attention mechanisms. So these have been accumulating step by step, but without one paper that was published somewhat recently, we would not have ChatGPT. So all of these are required. That's my main argument. And then going through these one by one. So if we start from modern CPUs and GPUs, I would make the argument that Second World War speeded up the development of the computers through Manhattan Project and other large-scale military projects from aviation industry where you needed to solve numerical problems. First computers were introduced in the 40s. Then we went from vacuum tubes, transistors invented, transistor computers, integrated circuits to personal computers. And then the graphical processing unit started to emerge mainly for computer games in the 1990s. And it was only about 15 years ago when these graphical processing units were started to be used for deep learning. And then we went to this hyperscale mode where tens of thousands or hundreds of thousands of these GPUs are being packed into data centers, and those require enormous electricity consumption. Then for the data part, I would argue that the World Wide Web was the killer application for the internet, and Tim Berners-Lee invented that in the very late 1980s, early 1990s. It started to emerge when first commercial browsers were introduced. Here's Mark Anderson, one of the contributors for Netscape, which was one of the first browsers. And the World Wide Web basically induced the demand for computers. So hundreds of millions of computers started to be connected to the internet. And it also created the biggest document collection that humankind has ever had. And this data set is being fed to the LLM models and modern AI applications. But I have to say that it was not invented for AI purposes. But let's go to the mobile technology then. So looking from the mobile communication point of view, I would date back to 1970s with the first cell pioneers, first commercial real mobile phones emerged in 1980s. Then 2G technology and Nokia and other vendors exploded the number of mobile phones in the 1990s. In early 2000s, we went for the 3G, which was first mobile internet. iPhone and other phones are somewhat recent innovation. I would say that that's the point where the phones converted to be more like actual computers and not phones anymore. And today we have billions and billions of smartphones, so almost everybody has one in his pocket. And it's necessary to understand that your pictures and emails and other data things are also stored somewhere. It's not only your phone. And these phones require enormous back-end processing scale, which is something that we call the cloud or hyperscale. And if we start going backwards from current reality, currently the hyperscalers are building like nuclear power plant scale data center facilities that require like almost gigawatt electricity consumption. Even the energy alliances are now recognizing data centers as a relevant industry scale electricity consumption industry, which was not the case, for example, 10 years ago. So somewhat recently we went from hundreds of megawatts to gigawatts, and if you date back the consolidation of this background processing capabilities, it goes quite steeply. So, for example, in the 1990s, early 2000s, typically large enterprises had like some kind of computer basements within the, let's say, 1 megawatt or 10 megawatt scale. But these enormous scale hyperscaling facilities have been introduced by the induced demand by the billions of smartphones. Then the last point is the scientific breakthroughs. Here we could list like thousands of papers. It's much more difficult to only name a few. But I would focus on the neural network development. So early versions of those emerged in the 1940s. I would also name the Turing test in 1950 to define what AI characteristics are. And then there was more neural network development in the 1960s. Backpropagation was first invented by Seppo Linnanmaa in 1970. And then it was reinvented in the context of multi-layer neural networks in the 1986. And this work was also recognized with the Nobel Prize. And then only in the last 15 years, the availability of the graphical processing units created what we now call deep learning, which meant that these neural networks can now have billions and billions of parameters, and we can scale them to use the existing hyperscale infrastructure more properly. But in the end, there's still this very important paper called "The Tension is All You Need," and that unlocked the capability of using these very large GPU farms to train neural networks in a new way. So they are not only being able to train them in a new way, but I would argue that this is also a new learning mechanism. And this is the last piece that was missing basically from the ChatGPT. But that was the main 5 points I have. So I would still go back to those. So these were the 5 things. So calculation units, data, mobile, small computers, the hyperscale needed, and scientific breakthroughs. If you have any thoughts on your side or any feedback for myself, so feel free to contact myself or post in one of the social media feeds or even send an email or suggest a chat. So it's always very interesting to hear if you learned something or if you have something to share with myself. And thank you for listening to this recording.